now you're wearing the computation on your head, but you're interacting in your space.
And we also think through using the physical space around it and the things in that space.
The way that it kills you is you take the robot's hand and it's so heavy it just falls on you.
Right? Like, because the whole thing is perceptually accessible. All the information is right there.
I'd say the majority of your experience should not be on the phone. You've paid all this money to go to a place. Hey, welcome to Cocoy AI, where we talk about career advice, creative outlet making, money, monetization, growth mindset, and the future to help guide creative folks through leadership, tech, and finding what makes them happiest in life. Welcome, everyone. Today on Cocoy AI, I have the honor of having Dr. Karl Fast and join in on our conversation. He has been doing user research or user experience since before Microsoft had a web browser. He's worked in startups, consultancies, and academia. He has a PhD in human information interaction and was formerly a professor of user experience. He's a co-author of Figure It Out, Getting from Information to Understanding. And I am so honored to have you here, Karl. I would love to have you describe the vision and mission of Figure It Out and how it aligns with your personal values.
Sure. Well, first of all, thank you for the invitation. It's always nice to speak with people who are interested in some of the things that I'm interested in, which is many things. When it comes to Figure It Out, the key idea of the book here really is that we live in a world with just huge amounts of information. And it is, especially now in the age of AI, it's not even that we have abundant information or overwhelming amounts. We have like essentially infinite information because these new tools can just spew more and more information. So the question that I have long had is how do we live well and think well in a world that is just utterly jam-packed with all this information? What does that mean? And we keep having more and more information that's thrown at us, and it's tucked into every nook and cranny of our lives, where it used to be that information was something that came in the newspaper or in books at the library, and now it's just everywhere. It's on our wrist, it's going to be on our glasses, it's going to be everywhere, right? This is a long-term trend in human history. And I'm more particularly interested in the idea of how information allows us to think better thoughts. The old idea has been that we just sort of consume information. Information is a product. Somebody makes that information, whether it's a book or an interview on a podcast or a newspaper article. And what we do is we step up to that information, we consume that information, right? We read it, we watch it, we listen to it, and then we will understand. And this tends to view information as a finished thing, something that we encounter and that is kind of out of our hands in many ways. But an alternative view is that information is much more of a process, that information is much more of a resource. And the process of using that resource converts it into understanding, that we use it as a material as part of how we understand, think, reason, plan, solve problems. It's not merely something that is just out there. And so the book is really interested in this question of if we adopt a view that information in all forms is a resource, what does that mean for how we can transform it into something that is more useful for the way we think and the way we live?
I'm wondering what inspired you to even focus on cognitive understanding and this whole idea of how does a brain work? How does it think? How did you get interested in that?
So that's a long story. I'll give you two or three major points along that way. The first one was in 1994. It's 30 years ago, basically this month or next month, that I saw Mosaic, which was the first graphical web browser. It had been out for about 6 or 7 months at that point, I think, and it was about 6 or 8 months before Netscape released their first version of a web browser. And so I started building websites that summer. And I was working as part of an atmospheric research group in the physics department. And what I learned very quickly was that I could build a thing that could work, but technically. But it was difficult for people to find the information that they were looking for. And if they couldn't find what they were looking for, then it didn't have any real value. And the answer to that came in this new thing that came out a couple of years later, which was known as information architecture. And the basic idea there was if you take the librarians have been doing this for a long time. And so if you take the ideas that and skills of librarians out of the traditional institutions, libraries, museums, and archives, and applied them to other domains like the web, they would have enormous value. And that was there's the key concepts there were, organization, labeling, what we call things, navigating, searching, and metadata. Those are like the fundamental ideas of information architecture. And putting them into the web and moving them into a completely different kind of information environment was a really exciting period in the late 90s. And then I wound up going back to graduate school. And in particular, I took a class on information visualization. And so the idea here was that giving people information in visual form can be hugely powerful because our visual system is like a high bandwidth interface to the brain, as it was often described. And so that was kind of a revelation because the web, of course, was so text based, and libraries and books were very text based, very text heavy and everything. And we tend to associate images and and video and things more with entertainment, especially back then, than we did with knowledge construction. The idea of like a video library for libraries, it's like, well, we've got all the movies that won Best Picture, right?
Mhm.
It wasn't the same kind of thing that we have today. And then the third real piece was that I read a paper, which I assume we're going to talk about a little later here. It was a paper about how people play Tetris.
Mm.
And the essence of this paper was that the way we interact with the world, with the information in the world, is actually it's not the result of our thinking, it's part of our thinking. And that paper was really the biggest epiphany moment of my life,
Mhm.
of my intellectual life for sure. I could not stop thinking about this paper.
I think it's interesting. It's touching upon, I know you're talking about finding, like using the librarian's toolkit to find things, but the paper that you're referencing on the Tetris, it's how do you do something? It's like how do you put that knowledge to action? So you find and do.
It's a little, yes, I would say it's a little more subtle than that.
Mm.
It's more about why do we act on the world? What is the value of acting on the world? And it argues that the traditional way that we have all been taught to think about how the mind works has a singular answer for why we act on the world.
Mhm.
So the basic story that is, you can imagine this in front of just think this in your head. Think of a loop with four parts. So you have the world as it is out there, right? You look around the world that you have right now. You got a book in front of you or a computer screen or a tree or whatever. You perceive the state of the world. So you take in sensory information through your eyes, through your ears, maybe through your hands where you're touching it. You're picking up information as you're walking. And all this information flows through your different senses into your brain. It's converted into electrical signals, and we've got this great, big, powerful organic supercomputer between our ears. That is when we think. We think with the information that gets converted into all this stuff that happens in our head. And this is what neuroscience is trying to figure out. How does that work at the biological level? And cognitive science is trying to explain the mechanisms of our thought. And then once you have processed this information, the thinking, then you act upon the world. And that's how you change the world. So cognition is this big, complicated piece that happens entirely in our head. Perception is input and action is output. And what the Tetris paper said is no, that can't possibly be the only reason. And we have data to prove it. And so the way that the study was set up was, well, what happens if people play Tetris? So Tetris, of course, is a pretty simple game, right? At least in terms of the actions that you do. You've got these little blocks, right? For people, I'm sure everyone has played Tetris, but for the one person on the planet who has not, and who is also listening to this podcast, you've got these little regularly shaped blocks that come in a couple of sizes, and they're going to fall down from the top of the screen. You move, and all you can do is you can move them to the left, you can move them to the right, you can rotate them clockwise only in 90-degree increments, or you can drop them down into position at the bottom of the screen. So four things that you can do. Now, in the classical idea of cognition, where you've got perception, cognition, and action, that would predict several things. The first is that you're going to suck when you start playing this, right? You're going to make a lot of mistakes. So you're going to move something 3 spaces to the left and then drop it down, but you really needed to move it 2 spaces to the left. But it would also predict that you would get better with time. You are going to accurately perceive, as you gain experience and improve your skill, that when you move it to the left, oh yeah, I only need to move it 2 spaces, and then I'm going to drop it down into position. So they did this study where they had people play Tetris, and then they compared the results to a computer model that they wrote, which also played Tetris. And this computer model was entirely based on this theory of cognition: perception, cognition, action. First you perceive, take in all the information, then you do this computing in your head, and then from there you decide on how to act. The theory would predict that as you play the game more, you would make fewer and fewer mistakes. When they looked at the data for human players, they vastly outperformed the computer player, and they didn't do, in many cases, what the computer was doing. And the computer, of course, was based on this classical theory of cognition. They would do things like over rotate.
Mm-hmm.
They would take extra actions. In fact, in certain cases, the best players would move the piece a whole lot more and rotate it a whole lot more. And they were like, what are you doing? A specific example would be the piece would start coming down and would just be visible, and they would suddenly start to rotate. Why would you do that? And they realized the computer would wait until the whole thing was visible before it would determine and perceive what the shape is. Whereas the human would be like, oh, if I just sort of spin it around a little bit, I can get a couple extra pieces of information. So I can get a sense of what this shape is going to be even before I can see all of it. Computer never thought about doing that.
I found that
It would
super
all
fascinating. Like the whole idea, it was not only that they were moving it, but they actually made more mistakes, but still would outperform the computer.
Yes. And this is the really interesting thing. People would deliberately do things that seemed like a mistake, but they only seemed like a mistake from that classical theory of cognition, because that classical theory would say the only reason to act on the world is when you know how to act. And if you made a mistake in your thinking, then you would act in an inefficient way. So the optimal player, the best player, would perceive accurately, think accurately, and move as little as possible. But the human players moved a lot.
Mhm.
So what they did was they proposed a distinction between two types of actions. The first type is what they called pragmatic action. And so the idea of a pragmatic action is you take steps to change the world to bring it closer to your desired goal state. That's a bunch of blah, blah, blah. Imagine that you're sitting at your desk and you've got a cup of coffee. You're thirsty. A pragmatic action would be to pick up the cup of coffee, lift it to your mouth, and take a sip and put it back down. If you were to pick up that cup of coffee and like pour it over your shirt, that would be a mistake. You have not achieved the desired goal state of having caffeine in your tummy. So anything other than that would not be what you wanted to have happen. So it's clearly a mistake. The epistemic action, though, is different. The epistemic action is about, epistemic from epistemology, as in of knowledge or creating knowledge and how we make knowledge and know what we know. So epistemic actions, they argued, were really done to make mental computation either simpler or faster or more reliable. And where reliable really means less chances of screwing up. You're not going to make as many actual mistakes. And this is what they saw in the Tetris study. So you've got a piece and you want to move it, say, all the, pretty far over and drop it into position. But making sure that it's lined up properly, that's actually difficult. It can be really difficult, especially when the piece is quite high up above the bottom of the screen. So what players would do is they would move it all the way over to the far edge, and then they would move it back 1 or 2 spaces until they knew, because they could see, they could perceptually line this all up. And they're like, well, let's just make sure. And it turns out when they did the careful measurements that it was actually faster to move over 2 spaces left and back 2 spaces and then drop it down than to get it exactly right the first time. Another example was you would rotate a piece and you're like not quite sure if that's the best position for it to be. So you would rotate it in the world and then you'd be like, oh yeah, no, the one before was right. So then you have to rotate it a couple more times and then you got it back to that earlier position and then you would drop it down. And what they figured out was when they did the math on it, doing the mental rotation in your head would probably take 400 or 500 milliseconds, where doing it in the world by rotating it on screen and then checking the result visually, that was only going to take you maybe 80 or 100 milliseconds. So it was actually much, much faster to do it this way, to use the world as part of how you are thinking. And so that's the basic idea of epistemic action. And we do this all the time, but no one had ever pointed it out.
Yeah. I mean, Tetris is such a interesting example because I play Tetris, and there is this one strategy where it's almost like it would look like a mistake on purpose because you're leaving a square underneath, but the whole idea is that the next piece that's coming, you're going to scoot it underneath, right? So from a computer's point of view, that looks like a mistake because you're leaving this gap hole underneath. And so that's like a human sort of strategy to do that scooting thing. And so how people think of that is this whole trying to figure it out visually as it's moving. Puzzle games are my absolute favorite thing to play. Actually, it's the only thing that I play on video games.
Related to this, that in the paper they give another example of chess, which for anyone who's a little confused, and I find the chess example really resonates with people. Imagine that you're playing chess and you pick up your bishop and you move it into a position, and as soon as you do that, you're like, oh, that's a bad move. But you haven't taken your finger off of the piece, and that means you can move it back. Now, from an interaction design perspective, you could say, oh, well, you did two things. You moved the piece, and then you pressed undo. And the very language of that we use in interaction design implies that you made a mistake. And from the classical perspective, you absolutely have. But when you understand this distinction between pragmatic and epistemic actions, you actually have not made a mistake. You, by move, the reason that you moved it and had to move it back was because you could not visualize the board in your head. But moving it made it very easy to see that this was a bad move. So you are changing the world in this epistemic action, not to change the world, but to change yourself and your understanding of the world. That's the value of the epistemic action. Now, of course, when it comes to chess, I'm talking about an amateur, someone who's just not very good. And a grandmaster would never do that. The grandmaster learns to do it all in their head. But just because a grandmaster can learn to do it all in your head doesn't mean that we all do. We can't all be playing, at the grandmaster level for every aspect of our lives.
Well, that's something that's a question that I had reading this example is that the goal? Should we be training ourselves to do more of these things in our head to become like that grandmaster just to like because it is training. That's how they do it over and over and over, thinking through all of the possibilities.
This, I think, is going to be a really, really interesting question in problem space as we work towards a world where we've got two things fundamentally happening. One, the obvious one here is that we've got more and more artificial intelligence, right? This potential other kind of thinking partner in the world. The other piece of it, I would say, though, is we're also getting better and better technologies, which are better able to sense and interpret and respond to the physical things that we do. Right now, we are really locked into a world where computation, for the most part, is on glowing rectangles of digital pixels. Imagine instead of putting a computer into the room or onto your desk, that we in a way go back to a version, sort of in a different way, where your room is a computer. There's a guy named Brett Victor who has worked on this for quite some time, this idea, and he had a project out in Oakland called Dynamic Land. And the notion of Dynamic Land is it is a physical environment where that is in itself an environment capable of doing computation. You are creating a physical space for doing thinking. It is loaded with technology, but the technology is almost entirely invisible to you. So there are cameras in the ceiling that can shine down and can detect the different things that you are doing on a desktop. And though you have different types of things which allow you to physically program and do computation in that environment. This is a very, very early stage kind of prototype project. And he envisions it as, this is like a 50-year research project in his mind about how we would actually get there. But in order to do that, we have to recognize that we think with the way we interact with the world, which means we think with and through our bodies. And we also think through using the physical space around it and the things in that space. User experience designers know this very well from a way we do a lot of, analyzing problems and doing data analysis and research analysis is where you get a wall and just fill it with sticky notes. And you use those sticky notes. You don't stand there and just, think about, maybe many of us have had these experiences where we're working on a project and there's lots of sticky notes on a wall and maybe a bunch of other scribbles on a whiteboard. What do you not do? You don't stand there and stare at the wall and think and then go, I know the answer, right? Like, because the whole thing is perceptually accessible. All the information is right there. Why do you need to move at all? And what this work on what is now known, what people talk about as the extended mind or embodied cognition or distributed cognition and a bunch of other terms, but all mean the same thing, is you do it because moving your body in and through the world and interacting with things is part of how you think. And it is an important part of how you think. You do not just perceive information and then think.
Do you feel like, or have you tried anything like the Apple Vision or the Meta Quest or any of these augmented or virtual reality things? Is it getting to that spatial awareness that that paper or that room that does all of these things gets to? Because now you're wearing the computation on your head, but you're interacting in your space.
I think that there's a distinction between, does it do these kinds of things really well, or is it on the path to doing those kinds of things? And I think we're right now on this sort of, this is a path. The way I've tended to think about the Vision Pro, which I have not yet tried, is that it's, this is technology from like 5 or 10 years down the road that we now have today. Sort of like when I was a kid, my parents bought me an Apple IIe in the early 80s. And well, it was definitely underpowered towards what came later. That was a very expensive machine. It was, I think it was like $3,000 in 1982 or $83. Like that would be a lot more money in today's dollars, and that's what the Vision Pro is. So this is, I think, on the path, but I think there's an awful long way to go there. And one of the big questions about it is, I mean, the first problem is you need to get the hardware right.
Mhm.
And then a later problem is, how do you do this interaction in a reasonable way, which understands the epistemic nature of interaction?
I would be thrilled to see what your review of the Apple Vision Pro is. The thing that I thought was really cool about it is it did scan the room. So all of the interactions had the shadow of what the room that you were in, it was in that three-dimensional space, which was really interesting to see. And I don't know if everybody would notice that, but even the renderings of the 3D things were rendered in the light of
No.
my space. It was pretty cool.
It's interesting their approach compared to other approaches in virtual reality or the Magic Leap. I mean, technically, just from a hardware perspective, this is an extraordinarily hard problem.
Mhm.
And the progress that they have made, I think, is quite significant. And virtual reality is slightly different in terms of, there's this feeling of you're going someplace else. And my struggle with them has always been, like, I used the HoloLens a number of years ago. And what was shocking to me was when I put it on was like, oh, my field of vision is incredibly narrow. And trying to interact with things was very difficult relative to the natural world. I think we undersell just the many ways that we do interaction. I was recently listening to an interview with the guy who founded Boston Dynamics, the robot company, and he was telling us a story about his co-founder and how his co-founder had sat down and watched like 20 or 30 hours of Julia Child cooking shows. And he was like, the funny, because trying to study how she moved and how she did things, because that's what they were wanting to do at Boston Dynamics, is create realistic robots that mimicked humans and other animals. The amazing thing was how rarely she used her hands to manipulate things the way the robot hands do. She would like roll things over and flop things around with her hands, and like just the classic example of like reaching out and picking up a cup. She almost never did that, but she used her hands in a huge number of ways. And in design and in robotics, even, like, there's just not a great, I mean, I think there's an appreciation in robotics for how subtle and powerful the hand is, but I don't think there's an understanding about how much it is related to, the way that we think. I've got a book called, there's a book called The Hand, which is all about this. And I recently picked up an MIT Press book from a few years ago, which is all about, it's called The Hand, I think, an organ of perception, which is all academic work on how hands are not merely this pragmatic extension of ourselves, but is much more profound in terms of how it is part of the way we think. There's research on gestures, for example, and how we use gestures and how pervasive they are, and how gestures are not necessarily for the person who is listening, but they're for the speaker as well.
I'm totally like this idea of the hand or the master's hand is like I imagine or would love to see something, I don't know if it's Apple Vision or whatever, have the master's hands. So you talk about Julia Childs. How awesome would it be to see her hands on top of your hands as you're learning how to
Mm,
cook? And you're going through, you can make it go slower, faster, any
right.
way you want, but it's the master's hands, whether it's cooking or playing an instrument or learning how to knit or crochet, you have somebody else's masterful hands right on top of yours to tell you exactly the movement that you should be doing in that moment. It's an interesting
Or
way to learn.
take a related example here, which would be that you want a robot to learn a skill that you know how to do,
Mm.
and that you could teach the robot how to do it simply by having the robot watch you do it
Oh, yeah.
or doing it with you. This is when I hear a lot of dooming type of stuff around AI and robots and how they're all going to kill us all, etc. An example that comes to mind would be, imagine two people who are going to want to dance and one person doesn't know how. And so one person does, and they grab that person like, oh, you do this and follow me, etc. The idea that we are anywhere close to a robot being able to do that is laughable. And yet that is a very simple thing. And you don't learn to dance by saying, we would like to have a dance. Here's what we should do. I'm going to give you a paper on how to dance, and you would read that. Instead, you would physically show them and do it with them. And so this kind of runs both ways. We're so far in many ways from creating robotic or artificial intelligence that has any sort of understanding of the world the way that we do. Which isn't to say that there aren't kinds of intelligence that they can't, intelligence, different kinds of intelligences, or ways that they can outperform human abilities. But I think that we have sort of a narrative in some directions, which is saying, oh, like we are all doomed as humans, and I just don't really see that.
What it made me imagine when you were talking about having a robot teach you how to dance, the way that it kills you is you take the robot's hand and it's so heavy it just falls on you and now you're squished
Right.
because robots
But
are heavy.
you watch like videos on YouTube of like these different robot competitions, they fall over all the time.
Yeah, right on top of you. I think that's how we die
Indeed.
from the robots. They
Indeed.
squish us with their steel frames. I think it's interesting to think of us teaching robots in a similar way that we might teach a child, right? And what are the different, it makes me think of how people learn and this whole idea of the brain and I think what was called like the radical side of the brain, or in my mind the kinesthetic way of learning and like physically moving something in order to make sense of it is an interesting idea. Like, do we teach the robots or even large language models in the same way that we would teach a child how to maneuver through the world?
And how do we learn on our own this particular way? I know that there is a proposal by Jan LeCun, who is the chief, I'm not sure exactly what his role is, but basically he runs all the AI stuff at Facebook, at Meta. And he has recently proposed that, very broadly, that we should train AI to watch YouTube videos of how people do different types of things and would able to learn from that. Like, how do you make an omelet?
Mhm.
There's plenty of videos out there about how to make an omelet, and it should be able to do this, which is an interesting proposal. And I don't know how far along they were at getting that. I think that for me, my main interest in a lot of this, to go back to the question that you had at the very beginning, was like, how did I get interested in this idea of, you know, cognitive understanding and information and how we use this to think? Coming from a background in engineering and physics, there's this desire always to make things, which I think is a human type of thing. And we like to create, we like to make things. I wound up in design, I wound up in user experience. And we make a lot of things for other people. And I am concerned, although that's not quite the right word, but I feel that what people in design are mostly doing these days is making things on screens in these rectangles. And our idea of interaction design is, well, whatever set of widgets I've got in Figma, that's interaction. And I'm like, that's not interaction. That is like the tools that you have available to you. But it's a very, very narrow idea of how and why human beings interact. And so a lot of the work that I have been interested in, and this is where a lot of the book comes in and the workshops and stuff that I've given over the years, is trying to help people sort of unhorse themselves
Mhm.
from this default way of thinking about action, which is really a default way of thinking about how cognition works. This idea that it all happens in the head. what is known as the computational theory of mind. And I'm certainly not the first person. I'm simply interested in some of the academic work here and how this translates to people who are actually going out and making the world, who are doing the design work, building our tools, designing our spaces, whether they're physical or virtual or whatever, to support a way where we can live with all of this massive amount of information.
I mean, I strongly believe that the digital space or the screen is a little bit of a crutch for design. I think thinking broadly, I'll give you an example. I was just speaking with my husband about a recent trip to Disneyland, and that has changed significantly for me. I felt like I was on a screen the whole time trying to see which ride is going to have the shortest amount of time, and I wasn't interacting with people or looking at the things around. I'm just trying to game the system that's on this little device. Could the user experience designer of that incorporated more of that into the experience around you rather than having to carry an extra battery because you will run out with the amount of time that you're spending on your phone in a very quick way? I'd say the majority of your experience should not be on the phone. You've paid all this money to go to a place. You should be experiencing that rather than your phone.
Well, I don't have a specific answer to that. In terms of what that's worth, because I'm sure there's a ton of really hard work. In fact, I know someone who did work on the Magic Band at Disney many years ago on from a UX perspective. But I do think that there's like enormous opportunities for design
Mhm.
around this, but a lot of those opportunities really require us to, the people in the design space to make sure they are thinking about these kinds of problems from an appropriate perspective with like the right mental or conceptual toolkit. When the one of the books that really opened my eyes to a lot of this, there were two that I read in the mid 90s. One I've already mentioned, which was the information architecture book, IA for the World Wide Web by Lou Rosenfeld and Peter Morville. The other one was Design of Everyday Things by Donald Norman. And that is actually from the mid 80s, 86, I think. And that book introduces a small set of concepts. It's not a very long book, although I think the new edition is quite a bit longer. But he introduces concepts like affordances and mapping and feedback and some other types of different ways of thinking about errors. And what's useful about that book is it completely changes your perspective if you don't know those concepts, to the point where it is impossible really to do design. You're like, how could I ever design anything usable if I didn't know these concepts? But what's also interesting is how those are broadly useful for almost any kind of medium that you're designing in. He was writing when the PC was still, he was writing before almost anyone had ever used a mouse. The Macintosh had only been out for a year or two and was insanely expensive and underpowered. So most people, if they used a computer at all, only ever used a keyboard and a command line. They didn't use a mouse. And most of the book, so therefore it doesn't deal with computers, but everything in that book is relevant to designing any sort of software interface today. And it's going to be relevant for the Apple Vision Pro, and it's going to be relevant for everything else after that. And so part of my interest has been, how do we give people a language that is going to be useful, that is built on what we know from the theory of the extended mind and like embodied cognition and that whole realm of ideas, which is, and the epistemic actions piece has been a core part of that for my own work.
That is so interesting. I'm thinking back to the 80s, and I think my first experience with the Apple was like a SE30 or something. I think it was only like one undo, but you could still do like a Bezier curve. I think that was that, like Illustrator existed, but it was only one undo. But that was incredible. What you could I remember thinking that was amazing. But I was a child. So
As opposed to infinite undo.
yeah.
Right.
Yeah.
So in the book, just to follow up briefly, in the book we have I have a chapter where I talk a lot about that Tetris paper and explore that, and sort of trying to draw a bit more of an broader picture of how all this relates to different theories of mind and how we actually go about thinking. But then it follows up with a chapter that is all about identifying different kinds of epistemic actions
Mhm.
and creating basically a language or a framework so that you can look at what people are doing and think, oh, that's the kind of epistemic action they're probably using here. And you would be able to look at what people are doing, whether it's in on screen or in physical objects or some sort of combination, to help interpret that better to further your design process from there. That's the kind of work that I have been interested in and for a long time, and that's where the book kind of goes in some directions.
Yeah, for me, I want to understand how to go into it and grow my understanding of how to use some of those frameworks to have more of a growth mindset and learn new techniques of remembering things. Like I am horrible at remembering names, and I've taken a conscious effort to figure out ways to tie a name and make it stick inside of my brain. I think that some of the tactics that I skimmed over in the book will be vastly useful. But what advice would you give listeners to this on how they can extend their minds?
So the chapter that we're talking about in particular lays out 15 different kinds of epistemic actions, and I break them down into 4 major categories. Some of them are fairly basic things like cloning, where you're just making a duplicate or a copy of something. A common one is what I call probing. Probing is where you are looking at something, you're like, oh, tell me more, show me more. I need another level or layer of detail about this particular thing. We can see these things all the line when we see a lot of these kinds of things online when we're searching for information. You're like, oh, that looks interesting. Show me more about that. Oh, let's clip a copy. Let's save a copy of that into a bookmark or open it up in a new tab. There's a bunch of different things. But of all of the ones that happen here, I think one of the most powerful and common that runs across all the different experiences we have is the power of rearranging. If there was one of the interactions here that I think is super, super important, that I had to pick one that is most important for our thinking, it is the ability to rearrange things in space. You've come back to that example of the sticky note, the wall filled with sticky notes. What you're looking for is patterns, typically. You're looking to see what is related to what. Is there a hidden pattern or is there a meaningful pattern? How do I find that? You don't find that by simply standing there and looking at it. You might get a hunch. You're like, oh, maybe this is it. But it requires you to pick something up and move it around and put it next to something else. And doing that helps reveal the pattern.
Mhm.
This is what you do when you're writing. You're rearranging words on the screen. There's a tool called Scrivener, which is a writing tool that is kind of like Word and totally not like Word. Because what Word does is gives you one big, long, huge scroll. And what Scrivener does, and Ulysses does a similar thing, which is more markdown based. But what Scrivener does is takes all of these different files that you have. You create little pieces and then you organize them and arrange them. You can actually get an index card view where you can see the whole thing as a series of index cards and you can drag and drop and move them around. So writers will use it in different ways. For example, I'm just going to write like this paragraph, I'm writing a chapter. This chapter is going to have 5 different parts. Each of these different parts has a bunch of different ideas in it. Each of all of these ideas would be a separate document that you could work on that document at a time. And then you can drag and drop and rearrange them.
Mhm.
There's a podcast where they interview people who are writers, published writers, some of them highly successful New York Times best-selling writers who use Scrivener. And they talk about, yep, I rearrange stuff all the time. Like I do this, I do this. This is part of how they work. And they talk about how Word is so limiting because it's just this one long thing and it's very painful to select something and move it somewhere else.
Especially if you have to go back and edit, it has like a different you make all these different versions. I'm interested in the Scrivener. I use Miro in a similar way where I'm kind of grouping things together. I'm like hopeful that AI would be able to help with some of oh, I want to see it grouped in this way, and then maybe help form some of these groupings for you, and then say, oh, well, what if it was grouped in a different way? And then just completely relay it out in a completely different way, because I think that seeing things grouped in different ways will come up with different insights, right? You'll get different ideas from various different ways things are grouped.
The other simple thing that people can do, I would say, is to think about how frequently, just through a course of a day, how many times you rearranged your world to make things simpler or easier or to prevent yourself from making a mistake. People do this all the time. The kitchen is a great example of this. right? Like you should be managing your space. And as you manage your space, that is part of how you think. Chefs do this all the time. There's actually a weird but very interesting little book called, well, it's variably called Mise en Place and sometimes called Work Clean. I cannot remember the author's name off the top of my head, but it is a book about studies of chefs and how chefs are trained and how they work and how they think by organizing and managing and constantly rearranging their space as part of cooking. But cooking is a very creative act. And he draws from this lessons about how we can organize our physical space around us for all kinds of different creative acts.
That is a really interesting example because I think the whole idea with the chefs is they have everything in place. That's a mise en place. Like they get all of the stuff out that they need for this particular thing, and then I don't often do that when I am creating something. I'm often going back up the stairs, going and finding something, going and finding something. But maybe if I took something from the chef's mise en place and just got everything together before starting, maybe it would go a lot smoother for that creative process, even if it's not cooking.
The rearranging one is very useful because it's so pervasive. When I've talked about this epistemic pragmatic action, it's very easy to get the sense that there's a hard distinction between the two of them. And in reality, there is not. The important thing is to understand that there is a distinction, that there are at least two kinds of reasons for which we interact with the world, and that often a lot of things have a very strong epistemic component, and we have not historically recognized that. But so when you're doing as a chef, they will organize things for very pragmatic reasons, but they will also organize things and rearrange the space for epistemic ones as well. Woodworkers would do that. Gardeners do this. Like we all do this all the time. And so part of this, when I gave the example of the Don Norman book, The Design of Everyday Things, what it did was it gave me a way to see things and talk about them that were always there, but I had not recognized them. I didn't understand what an affordance was. I didn't understand really what mapping was. But once I read the book, I'm like, oh, and I began to see it all over the place, especially things that were mapped very poorly or when the affordances were very weak. And by thinking about interaction and how it helps my thinking, I can see rearranging all over the place. I can see interfaces where I'm like, oh, if only I could probe here, if only I could probe in a way that took me one step instead of five. Those kinds of things has given me a very much a new lens on how to do this. And I think I'm hoping that will be true for the readers as well.
Yeah. I am really excited about getting to dive into your book. What are you most excited about in this upcoming time?
Well, there's two major things that I'm interested in. One is this whole space of personal knowledge management, tools like Obsidian and other kinds of tools, because I see a lot of energy in that space, a lot of creativity, a lot of possibilities. There's enthusiasm that reminds me a lot of the early days of the web, where you've got a small group of people who are really geeking out in an area that almost everyone else is ignoring. And they are also doing that where they're trying to use information as a resource to improve their thinking as a way of dealing with all of this, this world of abundant information. So that's, I think, is a very interesting space that I'm keeping a close eye on. And my colleague Jorge Arango and I have done workshops on this over the last couple of years and talking with people and helping do that. The other thing that I'm very interested in is AI, but not the way I think most people are. And I know this is a topic of interest to you in the podcast, of course, and your listeners. I think that most people are interested in AI in terms of the tools themselves. How can I build models? How can I learn the technology? How can I use ChatGPT, etc.? I am interested in it much more in terms of how do we think about and conceptualize the relationship between human beings and AI, between a chatbot or various other kinds of generative AI tools. And how does the way that we think about that, what opportunities might that open up? So, for example, I was just this morning actually reading a paper called, it's a preprint paper that on Archive called Designing for Work with Intelligent Entities. And so he points out that people have been talking about intelligent agents in the human computer interaction literature for 30 years, and in the AI literature for just as long, if not longer. And he breaks down this whole conversation into three camps. There's one camp which says AI is just a tool. So you should think of it as like a piano or the blender in your kitchen. Like it doesn't do anything unless you do something. The other way of talking about it is AI as teammate. So this aligns more with a more popular way of talking about it that I've heard a lot is, think of an LLM as being like an intern. You can give it something to do, but you definitely have to check the results. You can't trust it. And you got to work with it to get to the point where over time it's going to become more and more reliable and hopefully also more capable about a broader range of things. So that's the teammate model. The third model here that he proposes is AI as joint cognitive system, which is very much along the lines of embodied mind, extended mind, embodied cognition, that kind of thing. All three of these, he points out, have different strengths and weaknesses to the argument. None of them is the sort of like the one true way, but each of them has consequences. If you were to use one of these particular ways, if you think about it solely as a joint cognitive system, you might wind up with a very different kind of result as a designer, right? As a programmer, developer, a product team about what you're going to make, than if you think of it as AI as a tool that's going to change what you think is possible and how you think that interaction and that partnership between you and the AI is going to play out. I'm very interested in these kinds of conversations because how we talk about things, the way we think that things work, our conceptual vocabulary really, really influences the world,
Mhm.
really influences what we do and how we approach things. And this has happened. This is a pattern that I've seen again and again. Like until I got the language of information architecture, I had seen the web fundamentally as a problem of programming. Can I make it work technically? And at the time, in the early days of the web, there were really only two groups that were fundamental. Well, three people who really cared in the mid 90s about the web. One, of course, was the people who wanted to make money. The second was the people who wanted to program the hell out of it, right? And the third was all of the graphic designers who wanted it to be just like print. And then these two librarians came along and they were like, hey, it's just a lot of information. We have a lot of useful skills over here. And that completely changed everything for me in terms of how I looked at what the possibilities were. Without that language of information architecture, a lot of sites just basically really struggled. They
Okay.
could provide the information and it could look pretty good and it worked on the back end, but you couldn't find what you were looking for.
I will say, like, graphic design has always had hierarchy as one of the core features. Like, if you think about typography, and it is helping people understand or find the information that they're trying to get at in a reasonable way. Maybe it doesn't go quite as deep as the librarians and trying to have the whole information highway of all of the data. How do you find it one piece? But I think that the 90s for web design was definitely a wild west, but like, for me as a creative person, seeing the very infancy of Flash and how a designer could create something that maybe wasn't only text or information on a page was really when I first was drawn toward, like a moth to a flame of the web, is being able to see something come to life in motion everywhere, like sharing this.
Yeah, my memory of that period was that graphic designers were right that the web was very exciting,
Mhm,
but they wanted a level of control that the web could not provide.
mhm,
And so two things needed to happen. One was that the technology needed to improve dramatically. you know, you needed to be able to show more than 256 colors on a page and not have a gray background for everything. You needed CSS, you needed JavaScript, you needed all of these other kinds of things. And so they were just in some cases too far ahead of the curve. But they caught up, right? The technology caught up, and then that gave them a whole lot of stuff that they could do. And this was, I think, very valuable because it also pushed the technology people to say, oh, this actually is important. And maybe we should make it a higher priority. I think that was part of what was really valuable about that. They were exploring things. And in a way, they were too early, and a way being early was very necessary. But then what also happened was that I think over time, as they got these more powerful tools, I think people who were trained in the print world of graphic design realized they needed to expand their conceptual palette of what was possible. They needed to stop thinking about fixed dimensions of the page and
Yeah.
having total control and recognize, oh, we need to think about fluidity. We need to think about how things could adapt and, as we call it, like responsive design. That was not really a concept in the world of the fixed printed page.
Yep, and now those concepts are so ingrained that it's weird if you see something that doesn't adjust to the size of the screen, whether it's on mobile or desktop. Well, Carl, I could talk to you all day. I mean, probably for days on end. I appreciate you coming and joining and having this awesome conversation with me. I hope to have you on again.
Thank you very much for having me. And I have a PhD. I was a professor for many years. I very much have the professor's disease of being able to just talk about all of these kinds of things that I find so interesting. So it's my pleasure, and I hope I didn't run on too long.
This is great. I think it's so fascinating. I have learned so much about the cognitive brain, and I hope to learn more when I'm as I read through the book in much more detail. Thank you so
The
much.
Well, I would add one last thing here. For anyone who is kind of interested in the book, I have another book that I'm going to recommend that you read first. This is a book called The Extended Mind: The Power of Thinking Outside the Brain by Annie Murphy Paul. This is the book that, when she published it, it came out in 2021, a popular science book meant for a wide audience that explains the theory of the extended mind and embodied cognition, convinces you of the science. In Figure It Out, that is what I try to do in chapter 2. And the whole time I was writing chapter 2, I was thinking, I really wish this was a whole book. I really need a book to explain people of this, because this is a really hard thing to understand. It seems easy, but to really get it requires quite a bit. And when the book came out, I contacted her and said, this is a book I have literally been waiting 20 years for someone to write. Because when I encountered this stuff in the early 2000s, and since then, I've read quite a few books, but they're all too academic. So they were helpful to me, but they were very unhelpful to a wider audience. And every time I picked up a book that was, more popular, that kind of seemed like it would be in that vein, it always fell short. So I actually tell everybody, including user experience designers, if they're interested in my book that Stephen and I wrote, read this one first.
Okay.
You will understand the science more. You'll get a sense of it. And then when you come to our book, you'll be like, oh, this is how, now that I have this sort of background, this is how it might play out in terms of what it means for designing things. Not that you shouldn't, not that I'm not happy if people read our book. I hope people do read our book. But that is a very accessible book, and I highly recommend it.
I feel like your book is also equally well, I haven't read that book, so I can't say equally accessible, but your book is very accessible to to a novice like myself. And
It is speaking to a different kind of audience as well. I mean, it is speaking more to people who are thinking about doing, not necessarily doing design, but making digital products and things, or any sort of like, interactive thing in any way. And it covers more than just the stuff I've talked about, but it does come from that perspective of extended mind. Annie's book is a lot more of like, this is an important idea
mm,
that most of us don't know about and don't understand. It's only going to become more important. And the science here, which goes back more than 30 years, is quite robust and is leading to a huge revolution about everything that you probably took in your cognitive psychology class in university.
and the last question, who should I interview next?
You did tell me about this question, and I do not have an answer for you because I forgot to think about it.
That's okay. You can get back to me on that one. But
I'm
I
trying to think of so
oh,
well, part of the reason is because I know that you talked to Jorge before this, and the people that I'm initially thinking are simply going to go primarily down more into the on the design and user experience route. I'm trying to think of someone off the top of my head here who would go in a different direction, or slightly different direction.
I think it would have been interesting to have both you and Stephen on at the same time to see what your how your perspectives wove together for this book.
I will have to get back to you on this one because I cannot think of anyone off the top of my head where I'm like, oh yeah, that's a slam dunk. That would be an obvious person. Here's someone that you might ask. I don't know him very well. His name is Dave Gray, and he has written a book, also published by the same publisher, by Rosenfeld Media. It's called Liminal Thinking. This is a much thinner book, but it is a different take on how to think well.
Mm.
He is writing as someone who comes from a background as a graphic designer, as a visual designer. He has written a number of different books, but his whole thing has been around visualizations and different ways that graphics can help us. Visualizations and visual information can help us to think. He has also wrote a book a number of years ago called Game Storming, And what game storming does is it's a book about essentially about embodied cognition, really, when he never really uses that terms, but it's different kind of physical activities you can do as groups of people to solve problems, to think through things in a fun, interesting, and engaging way. But it's very much like the body has to be involved in the whole process. It's not something that you can do especially well over Zoom necessarily. And so he has a different kind of take around this, which I think is interesting and tangential to this, but not unrelated. And he's got a design background. Very good at what he does.
Awesome. Thank you, Karl.
You're welcome.